I'm going to give him a quick introduction. So Wayne is currently the global head of detergent and grease technology for Lanxess, leading a highly skilled, dynamic, and dedicated team of chemists at its West Hill, Canada Application Technology Center. He's also currently serving as the NLGI President, 2024 to 2026, and has represented Lanxess on an NLGI board since 2012. He's a recognized expert in the design, manufacture, and use of calcium sulfonate complex grease, and has developed over 150 grease formulations for use in a broad range of applications. He's also active in the development and introduction of new detergent technology and formulations for lubrication, corrosion inhibition, and grease manufacture. Wayne has spent the majority of his 30-year career as a scientist, but has also held roles in marketing and asset management. He's authored more than a dozen technical papers, contributed to numerous journal articles, holds 2 patents, and has given more than 25 presentations at leading conferences, seminars around the world. He has a master's in materials engineering science with a focus on tribology from the University of Western Ontario. He also served on the STLE Board of Directors from 2008 through 2011 and remains active at our local section. He's been awarded the NLGI John A. Belanti Memorial Award in 2019, NLGI Golden Grease Gun in 2021, and the Award for Educational Excellence in 2022, as well as the NLGI Fellows Award in 2023. Finally, in November 2023, he was awarded the Lanxess Robert W. Brown Award for his technical contributions over his career at Lanxess. So I'll turn it over to you, Wayne.
Well, thank you. Thank you, Jeremy. He's one of my, what did I call it?
Highly skilled, dynamic, and dedicated.
Which one are you?
Dynamic.
Dynamic. All right. Anyway, welcome everyone. Welcome everyone online. Thanks for joining today. When Jeremy said that he was taking over the chair role this year, local section, I said this would be a unique opportunity that that I could speak on behalf of the NLGI, which is I won't say a sister organization, but certainly an organization within the same sphere as the STLE. And so it was a unique opportunity for me to come out and speak. So I was going to talk for a few minutes just to give you all an update on who the NLGI is, what we do, and then I'll go into a presentation on grease and testing, which also relates to NLGI, as you'll see. So NLGI is it's a global organization. It is based in the US. It started in 1933, so it is a little bit older than the STLE. It started, and it is a manufacturers association. So it's a global organization with over 260 member companies. Membership is by company membership, though. So there are not individual memberships like the STLE. It's by company, but anybody who is employee of said company is a member of the NLGI and can obtain all of the benefits as a member. We have one chapter, the India chapter, which was started many years ago. They currently have 35 plus member companies. They mostly do their own thing, but we do liaise, and of course we provide the background and some of their resources to operate their chapter. And our mission really is to be the go-to resource for grease information and support globally. Now we operate our society or our industry association on a group of strategic priorities. And every few years, the executive committee and the board review these strategic priorities and make some changes and align them to what we see as the next several years of our existence. And those include education and networking opportunities, membership value, engagement and growth, global outreach, future leaders, and technical leadership. And since I've been president, started 2 Junes ago, so I'm in my 2nd year of the presidency, I've really focused myself on future leaders and I guess global outreach to an extent, but mostly on the future leaders. I'll explain that a bit. So we have a highly active membership. We have 23 board members. And again, those board members are by company. So the company has that seat and they put a person on the board for the most part. And right now, certainly all of those are certainly champions of the executive and or of the NLGI. So we're very lucky to have board members who are very active and supportive of what we want to do. We have elected by the board our 5 executive committee members, president, vice president, treasurer, secretary, and past president. And these positions really do move through a sequence. We have changed it a bit, but historically, when I joined, it was basically a 10-year effort. So it's 2 years in each position. It's changed slightly, but certainly vice president, president, and past president are all 2-year terms each. So it is a commitment. We have 4 permanent staff that we've hired. We have over 85 volunteers, but there are over 200 volunteer opportunities. So many of those volunteers do multiple duties, and that is mostly done on our committees. So we have 33 active committees, ranging everything from governance all the way to sustainability, education, etc. And each of those committees are now staffed or contain about 8 people, 8 members on each committee, and they provide the running of the NLGI. And that's really where a lot of everything comes through our committee structure. So some of the things that we do, one of the things that we're very noted for is we have a global grease production survey. We put this out every year. We've hired a third party to capture and collate all of the production data that they can from the various grease producers. And they collate it and scrub it of any ability for the NLGI itself to tell whose data is what. So it's aggregated and that's provided back to the NLGI, which we then provide to our membership. It is quite a good survey, but it is just so if you ever do get a look at it, and as a member, you have access to that. It is by production. So it's by region and by production. It's not sales. So it does not necessarily represent sales. So you could be producing grease in North America, but some of that grease could be being sold in Europe. That it doesn't tell you that, but it does tell you how much is being produced within the region. And it's a very handy tool to track annual changes. And I'm going to talk about that in my other presentation. We'll see a bit of that. It's a very, very useful tool to understand what's being produced, what the trends are, etc. We also do a lot of, we've really gotten into industry research, and we have funded over $500,000 US since 2017 in targeted research at universities. We have since upped that to $100,000. So it used to be $50,000 was the grant, but we've moved that to $100,000. And the research has to be something that the whole association can use. So it can't be targeted for a given company, but it's aggregate research that can be used by the membership. And so far, I believe there's been about 10 projects that are either completed or underway. And at the end, they are obligated to provide a research report that we then can provide to our membership. The other thing is that we have technical papers in our journal that go back to at least 1941. And we have since digitized all of those, and they are now available to search and to print and to use by our membership again. And they're very, very handy. A lot of great work's been done, and they're a great resource to go back to. Surprising how much the wheel gets reinvented over and over. We also provide certification marks, and that I will, again, part of my other presentation, but historically, you've probably, if you work in the grease industry at all, you've heard of the GCLB certification, which is was designed and launched in the late 80s as a wheel bearing specification for grease, but it quickly became a de facto specification for a good grease. And many people have used it, and we have quite a number of companies that are certified to that. As I will discuss later, we have since launched a new and improved version. Now, the wheel bearing grease, the GCLB remains and is still very active. We're not looking to remove it or replace it, but we have offered and have launched what we call a high performance multi-use grease, which is mainly tailored to our current age. It's more in the 2000s and looks at some new test methods and new ways to characterize grease that gives us a better look at what represents a high performance grease. And we offer certification against that as well. So again, we have over 28 products registered. They also have some enhancements, which I'll talk about a little later. But you can go to the NLGI.org and you can see who is registered, what products are registered, and how you would go about registering your own. And we've been doing a lot of marketing. I've been giving this presentation or presentations on HPM this past year at various conferences, and more people are really starting to see the value of that specification. One of the things we do is we have an annual meeting. Can't have a society without a place to gather, exchange ideas, have a little bit of fun. Our previous meeting this year was in Fort Lauderdale in June. It's always held in June, typically the second week in June. And it was themed as driving future reliability, tied to that HPM specification. We had almost 500 attendees. About 50 of those were spouses or partners, and the rest were people within the industry. And you can see some pictures here from various things. It was held on the beach. It was very nice. We definitely have lots of networking, but also, as you'll see here, at our upcoming meeting, I got a list of all the different things. We have technical sessions. We offer basic and advanced lubricating grease courses. We have our CLGS exam, which is similar to the CLS exam at STLE. We offer tabletop displays, so we're not a huge exhibit hall, but we will offer tabletops within Meeting Central. We have an industry speaker. We have a golf tournament, various networking receptions throughout the week, and then we have a very renowned closing party. And this year, the theme is The Heat is On, because it's being held in Palm Springs, California in June. It's not going to be cool, but we're looking at greasing in the extreme. So it's all about developing grease for the extremes in operating conditions. And again, we anticipate well over 500 attendees. And then our future annual meeting, we have booked, locked and loaded for Miami in 2027. Again, that second week in June at the JW Marriott Miami Turnberry Resort and Spa. We are just working on the 2028 conference, which we had thought might be Puerto Rico, but the resort was very nice, but unfortunately the June is not a high time for employees. So we were very concerned that there would not be enough staff to actually run their holiday season, or their high season is not in June. It's earlier in the year, so there is a staffing concern. The last thing we want to do is run a conference that everybody remembers for not having food or any service. And then I will point out that in 2022, we held our second conference in Canada. We had the first one in 87 or 88, and then we had one in 2022, just coming out of COVID. Attendance was a little poor due to that, but everyone liked Toronto, and we are looking to come back possibly in 2029 to Canada. We're looking at either Ottawa or Vancouver. So, and then Toronto's always in our back pocket because we know that one will work. So we are an active organization. Here's a picture of our executive director, Crystal. So she manages all of the day-to-day and our staff. And then we as the board provide guidance and direction as to where the NLGI should go. And they execute that part of it. So that's the NLGI in a nutshell. It is a very interesting and rewarding organization, and I think it stands quite well beside organizations like the STLE. The STLE has its place. NLGI has its place as well, and it is a very, very good place to network and to trade ideas amongst yourselves. So I don't know if you have any questions. Yes. Yes, I will be. Yeah, I've built that into my other presentation because it ties better with the technical side.
I guess any questions online about the NLGI before we jump over to the HPM? All right.
All right. Right. So I put this together. Depending on, you may have seen some of these pieces that we've presented certainly in the past as Lanxess or as Kentura even, gathered some of this together. But I want to give you an overview of lubricating grease and then talk about the methods to characterize its performance, in particular tied to the NLGI specifications and the tests that we've chosen for those. Just very quickly, because I'm here representing Lanxess, just so you know who we are, who Jeremy and I and James here, and, I know there's a few online. We are part of what's called Lanxess Lubricant Additives. It's one of 9 business units within Lanxess. We're the only unit based outside of Germany, and we're based in Shelton, Connecticut. We have quite a number of customers. We have a very large product line, 12 global manufacturing sites, 2 of which are on either side of Toronto, one in Elmira and one here in, well, part of Toronto in West Hill. And we certainly have a lot of expertise. And then the other thing is we have at the moment 5 global technical centers, and the one that Jeremy and James and I and others work at is in West Hill for detergents and grease. So what is a grease? The different greases, characterization of grease, the changing grease market, and I'll summarize it all up. So that's my agenda for today. So I won't get right into it. So finished grease, it's really a 3-legged stool. It's comprised of 3 components: a thickener, an oil, and additives. The thickener is the gelling agent that holds it all together. It can also impart some properties, such as wear protection, EP, anti-wear, etc. But its primary task is to gel the product. And the product that it's gelling is oil. So that is the primary component. Typically makes up 60 to 90% of the finished grease is oil. We'll call it an oil, but it's a fluid. And it is what imparts most of the lubricity in the finished grease, but it also keeps the grease fluid in a sense. If you didn't have that oil or enough of it, the grease itself would be much too thick to handle. And of course, there are many options available, which I will discuss. Additives are the part that give you that enhanced performance. So sometimes you need it, sometimes you don't. But there's a whole range of additives, much like in lubricating oils, very much the same chemistries, and some different ones are used to enhance the performance of the grease. And they can comprise anywhere from 1% to 20% or more even of the finished grease, depending on what you're putting together. So why use grease versus oil? Grease is very good at sealing out contaminants. It reduces dripping, misting. It's a great way to suspend solid additives if you want to use those in your application. It's probably the best for intermittent operation because it stays where it was. So when you stop the equipment, it remains in place or should remain in place. So it's there and ready to go when you turn the equipment back on. And then, of course, extreme operating conditions, especially things like high loads, high temperatures, high pressures, shock loading, immersion, submerged, etc., and really changing conditions. So where the operating conditions can change, it favors grease. Oil, of course, really needs to be pumped in some way to best lubricate the products. And when not in use, of course, gravity pulls it down, so it exposes the surfaces. You need to coat those surfaces effectively when you start up, or else you're facing friction and wear. Very difficult to shield from wet and contaminating environments. I know it can be done, but it's not a cost-effective way, where grease would be a much better route to doing that. And it's really not as effective for shock and changing loads. It really favors those nice continuous operations once past startup and you get into a nice smooth operation. That's where oil works best, oil films. So the thickener, main role, as I say, is to gel the product. And there's a whole bunch of thickeners that one can choose from. This is not an exhaustive list, but it's typically broken into two sides we call soap and non-soap. So soap would be traditionally, of course, a hydroxide reacted with a fatty acid. The simple versions are literally that. Calcium, lithium, hydroxides reacted with a fatty acid. And there is also lithium calcium where you blend the two. And then the complex version takes basically that simple soap, in a sense, and adds in some complexing acids, carboxylates, etc., to give it additional thickening performance and to change the crystal structure of that thickener to make it into something more. We call it complex because there is more than one operation taking place, but they typically have much higher temperature performance versus the simple products. The non-soaps are things like clays, polyureas, where there's no metal. There's a number of others, just simple dispersions of molybdenum disulfide or graphite can work. And there's a whole host that are coming on the market, polymer type and whatnot. And then in there is calcium sulfonate. Now, we like to think that there is some soap present. There is typically some calcium 12-hydroxysteric acid present. So one might even say it's a hybrid, but it lands in the non-soap portion, but it uses calcium sulfonate as the starting piece in its thickening. The role of oil, this is, as I say, the part that gives you the lubricity and basically gives the product fluidity. It also, in a sense, in the past anyway, certainly with mineral oils, was the cheap part. So the more oil you could get in, the cheaper your product could be. That may have changed now. Oil's not as cheap as it used to be. So adding more oil might actually increase your cost. But certainly when you move into synthetics and other products, then it can be the high cost driver within your formulation. And for this, we typically break them into the API groups. So the mineral oils are the group 1s, 2s, and 3s, and some variations in there. Those are typically paraffinic basis. They may have some aromatic and naphthenic present, but they're primarily paraffinic. And then the different groups, of course, offer the lesser sulfur, lesser aromatics, etc. These can be go through a whole range of processing, from just simple historic solvent refining through hydrotreating, partial hydrotreating, hydrofinishing, to almost near cracking in terms of the group 3s. So there's a whole range of processes there that all fit within what we still consider mineral oil. The group 4s are PAO only. That's all that fits in that. They're synthetic PAOs. They got their own group all to themselves. And then everything else gets lumped into group 5. And I personally still think naphthenic should be up in mineral oil, but everyone tells me it should be in the group 5 bucket. But you have your bioderived, your esters, your silicones, your PFBs, everything kind of gets lumped into that group 5. Primarily synthetic products to a large degree. Additives, of course, anything you can think of can be thrown in there as an additive. You know, that's as an additive producer. You see a lot come through the lab and what people think might or might not work. But it's all about imparting additional performance. But it can impart performance in 2 areas. One of them is it protects the bulk grease. So things like antioxidants, etc., are really more about controlling the bulk grease properties, whereas there are also surface active type additives that are more about protecting the component. Now, everything together protects the component, because if you don't have an operating lubricant, then you generally are not protecting the componentry. But you can sort of see it as 2 sides, that one is about the life of the lubricant and one is about the life of the componentry, that which you're lubricating. And so in the surface side, you've got your anti-wear agents, and there's all kinds of chemistry there. Your corrosion inhibition, again, a range of materials there. Extreme pressure, friction modifiers, metal deactivators, seal swell agents. And in this, you generally use combinations or multiple of these, depending on what you want to achieve. And you typically, if you're adding a sulfur-based extreme pressure agent, you're generally going to upset your copper corrosion. So now you have to add some metal deactivator to balance that. But you also then may affect your actual overall rust. And so now you have to add a rust inhibitor, and they all have to be compatible. So it's a really complex art in terms of formulating. Grease, you get a little bit of a pass on that because, again, you're in a thickened product. So it's not the same as in a motor oil or in an oil where you would actually see a gel form or particles or whatnot. You can hide some of that incompatibility within the grease, but incompatibility is still incompatibility. And so there is a lot of art and work goes into finding the right additives. And the other thing is that one additive working in an aluminum complex grease will not operate the same way in a lithium complex grease. You have to balance and understand how those things work. So again, it's a very, it's more than an art. There is a science behind it, but I still do think it comes back to a lot of artistry in terms of knowing what works and doesn't work. Yes.
So when you are from 0.1% to 20%, so all those are greases, additive percentage. When stop cleaning grease can be replaced? And what is the NLGI take on that?
NLGI doesn't have a take on it. If you can measure a penetration, then it would still be considered a grease. Now, it just depends on what is causing the gelation. But again, that would probably fall under the other in terms of if you wanted to label it as what is the thickener or what is causing that thickening. If we were to categorize it, it would probably just fall under the other category. But paste, I mean, could be a grease. I mean, it really comes down to an interpretation. NLGI doesn't have a position on it. Let's just say that.
So you find in the market some, say, NLGI 40% of all, whatever, which might not be economically, might be something for our space or something, but then you can still pour the grease.
You probably could.
But there's no way.
But there's also somewhere, again, like a anti-seize compound, you would not want to use it as a grease. So the operability as a grease might be suspect. But I don't think you would necessarily out of the block say that's not a grease.
What block grease? Number 6?
Hmm?
Block grease number 6?
Either 5 or 6. Yeah. I mean, I've never seen one. I don't know. I assume they're still made for some very special.
All Paulson bearing, paper bearings,
Right.
laminated bearing.
Okay. Does that answer your question?
Thank you.
And the last one is colorants. The last person who gave this presentation, Jesse, one of my chemists, put this one together. I changed it a little bit. I didn't want to be quite as facetious as he was. But basically, colorants, of course, don't do anything. There's no performance with respect to colorants, although there are some old thickeners based on what is a dye. There are some old dye chemistries used in high enough amount will cause thickening in a dispersion type. So there are some old greases, but colorants themselves don't do anything. It's all about marketing. Zinc oxide as a colorant might well impart some performance. So that one, there is some possible wear protection with enough zinc oxide. It may provide some wear benefit. But the true colorants, the oil-soluble dyes, are not a performance enhancer in any way. And I will just say, I know marketers will say, they'll sell a line of grease with different colors and say this one's for high temperature, this one's for low temperature, and that's fine. That company wants to try to sell that, but that doesn't mean the next guy who's selling them is their blue grease is the high temperature grease. So you can't use that sort of. There is no universal adoption of that. Same with the end users.
They're even worse. You know that.
So just be careful with anybody who's saying that this grease is for high temperature because it's red, or this grease is, or we color our high temperature grease red. Well, everybody else may not. So that you have to look at the actual grease characteristics, not the color. And then just I wanted to point out, and this is driving most formulators, including ourselves, nuts, is there is so much change in regulations. With the advent of REACH in Europe and what has tumbled out of that, the first rounds were a little bit easy. Now what they're doing is they're going back and they're looking at all of the substances of high concern, very high concern, that they sort of passed over in the grandfather stage. They're now coming back and requiring companies to do further testing on those. And the discovery is some of those chemistries are proving to be concerned, particularly around reaper toxin has become the new issue of late. And so the big one that sort of hit the market was the alkylated butylated diphenylamine. So the SIBA L57, the Lanxess Noglube 750, that chemistry is now labeled as a reaper toxin. It then triggers a reaper toxin label on the finished grease or lubricant. And that was the one used in food grade products. Now it's got this labeling. But under the rules of use of those products, you can still get away with industrial and commercial use, but consumer use becomes an issue. So products, consumer products, where you or I can go to Canadian Tire and buy lubricant, those are where you now cannot or will not be able to sell certain hazard levels. That will not be available. So these are basically coming off the market. And the problem with the alkylated diphenylamines is the other versions may face future scrutiny because they're also doing a lot of read across now. Rather than do extensive studies, unfortunately, harm or kill more animals, they are making the decision that once the body of knowledge hits a certain percentage within a class of chemistry, they're starting to do read across, and they're basically saying no more testing. We're just going to simply say the odds are that this will face the same regulatory issues that the previous 50% of that chemistry has, and we're just going to simply label them going forward. So that's a concern within our market space. So a lot of the formulators, and that's just one example, borates are another. PFAS, of course, is driving everyone crazy. And unfortunately, a number of the performance additives and thickeners potentially have PFAS present. So that's a big question that everyone asks now when you're formulating, when you're selling a product is, can you give us a letter that you're PFAS free, your product? So again, these are all the things that are changing, and we're having to find alternate performance additives and chemistries to fit into that. So the different greases, I mentioned that there were the two types, soaps and non-soaps. On the simple soap side, as I mentioned, there's the lithium, the hydrated calcium. So that's the original grease type was the hydrated calcium. The anhydrous calcium, which uses instead of a simple fatty acid, now it uses 12-hydroxysteric acid, which improves things somewhat. And then there is the lithium calcium that I mentioned that some people are moving to. So the lithium, and when we say lithium, we're really meaning lithium 12. I don't think anybody makes a simple lithium anymore. So it's all lithium 12-hydroxy. They're actually excellent greases. Dropping points are typically around 200 degrees C or a little bit above. And with different additives, you can bump that up a bit. They're a multi-purpose grease. They got good water resistance. Their upper temperature limit is limited to about 135 C. But you know what? For the majority of the applications, lithium works pretty well. Of course, you have to additize for just about everything in terms of performance. But again, a lot of work's been done. And there's certainly a host of chemistries out there to make these into decent greases. The anhydrous calcium has good water resistance and good shear stability. It does not have as high an operating temperature as the lithium 12. And it tends to find most of its use, I think, is still in food applications where temperature is not as important. But as I say, it brings out water resistance to the board. The blending of lithium and calcium is one thing that people are using to get around some of the issues faced with the cost of lithium metal and lithium hydroxide from the battery market. So there are companies that have had lithium calcium out on the market, but others are getting into that. And basically, it's just a co-reaction of lithium hydroxide and calcium hydroxide with 12-hydroxysteric acid. So you just replace some of the lithium hydroxide with calcium hydroxide. The temperature performance drops a little bit, but overall, they're not a bad product, again, for the applications that they're used in. On the complex side, as I say, we add those additional complexing agents to increase the upper temperature operating limit of the products. And the most common ones are aluminum complex, lithium complex, and calcium complex. I think calcium complex is probably faded to a large point. It's not used very often. But aluminum complex is very huge in food processing and in mining. It has a good high dropping point, good mechanical stability, and very good water resistance. It's also used in steel. But really, the workhorse in this space is the lithium complex. It is all around an excellent grease, very high dropping point, good mechanical stability, good pumpability, good bearing life at high temperatures, well formulated. These are very good high temperature operating greases, and they will be seen in a range of applications. On the non-soap, I'll come back to the calcium sulfonate. We'll start with the clay. Very good heat resistance. They're good in oxidative stability because, again, it's that clay structure. There really isn't anything to melt. or to oxidize at the temperatures that anybody might operate these under. Really, it's the upper operating temperature is the point at which the oil begins to evaporate. They have good water resistance. Their mechanical stability can be a bit suspect, and they are essentially incompatible with most other thickener types. Just the way their structure is put together, they get disrupted quite easily. Silica is very similar, very good heat resistance, and again, the upper operating temperature really is focused on the performance properties of the oil used, but it has very poor water resistance. You can improve that with some treatments, but again, that's not a good area for them. And I mean, I don't see them used a whole lot, but they're in some specialty applications. The other one that is very popular, especially in the Far East, are the polyureas. So these have no metals, they're metal-free. By being metal-free, it improves the oxidation stability considerably, but the structure itself has good oxidation performance. They have very good high dropping points, good mechanical stability at high temperatures. These are typically the electric motor bearing greases of choice, and they're definitely operate well at high temperatures. They generally don't have a lot of EP anti-wear. You have to formulate for that. And when you do formulate for that, unfortunately, the high temperature tends to fall off. So they still operate quite well, but what we would call the polyurea complex products, where you build in some EP and anti-wear, etc., they are not as high an operating range as the pure polyurea products. And then finally, calcium sulfonate, all-round excellent products. They have all kinds of inherent properties like corrosion resistance, anti-wear, EP, excellent mechanical stability, very good thermal stability, but they definitely need antioxidant. Some of the highest dropping points in the business. The one issue with calcium sulfonate is that it tends to be a much higher thickener content, which can limit bearing speeds and the size of bearings that can be lubricated, as well as low temperatures. But quite honest, given the right oil viscosity, and some processing conditions, you can formulate away from a lot of those issues as needed. Any questions?
You didn't mention anything about low temperature heat
In which
for the thickeners.
I'm going to talk about, well, I'll kind of talk to a degree here in the grease characterization. So there are so many different ways to characterize grease. It's probably, as a lubricant, one of the most tested products, or has the most tests available for it. And certainly it seems like everybody wants some different test run because they're familiar with that or it works well for them. As I'm going to describe, NLGI has kind of come up with a set of tests that describe a very good grease. But on the physical characterization, everything from visual and tactile testing to penetration, which I'll talk about, infrared technology, metals analysis, all of these things can be employed. There's even now a tackiness tester. Phalanx has launched, and I would assume Kohler's got one as well. There is now a way to measure and characterize the amount of stringiness that for 90 years everyone got away with the finger test, which seemed good enough. Now there is an actual characterization test for tackiness. Performance characterization, as I say, everything from mechanical stability, oxidation stability, lubricity. There's all kinds of tests, and new tests come out all the time. And then new ways within that test to characterize it. So and remember, there's the physical test itself, and then there is the conditions under which that test gets run. The permutations and combinations of all the testing, it can be mind-boggling what is the best to choose. But it's all out there. You can test just about any performance characteristics you can think of. There's even dynamic bearing tests that measure wear or life or noise or torque or corrosion. The other one that's very important for grease that's not common in other ones to a large degree is physical pumpability. Things like the US Steel Mobility Test or the Lincoln Vent Meter, or even rheology. Rheology can be employed to characterize the potential to pump a product. Very important testing. So the two that I'm just going to highlight, because they're the ones that get talked about the most about grease. One of the ones is, again, unique to grease itself, is the dropping point. And basically, it's a very thin film of grease that is heated up, and we look for the first sign or the first drop of oil to fall at the bottom of the beaker that it's held in is called the dropping point. And then there's a little calculation to relate to the temperature of the block versus the temperature that you measured, but you end up relating it to what's called the dropping point, and it's basically the temperature of that drop of oil. The other one, and again, that can be affected by the thickener type. That's probably one of the biggest effects, but it can be affected by the oil used, the viscosity of the oil used, the NLGI grade. All of these things can affect, and even additives can affect that point at which the matrix of the grease wants to release that oil and the temperature. So there's a lot of ways that can be boosted or negatively impacted. It is a decent quality assurance test, but as I'll discuss in a bit, it's really become not a test to characterize one grease versus another or to tell whether a grease will operate at higher or lower temperatures. It's less value than that, more value in a QA test. And then there's the cone penetration. So all grease at this point is sold based on its consistency. Because it's a gelled product, you need some way to tell whether that amount of gelling is what you need for your application. And so that is what we call consistency. It's measured currently by a cone penetrometer. ASTM D217 is the most common. It's the full scale penetrometer. It really, the depth of travel into that grease is the amount of penetration. And that penetration then is related to an NLGI chart. So to make it simple, somebody at the NLGI long ago decided to create a grading range because the penetration is measured in tenths of millimeters, and there was no way. I think it was probably getting pretty confusing. Yeah, no, I've got a 380 pen, and no, I really need to sell me a 370 pen or a 355 pen. There's no way to relate that. So we created a grading range that separates it into, and I just went from 4 down to 000. So a very, very stiff grease down to a very fluid grease. There are 7 stages displayed here. Each one has 30 units wide, so it's plus or minus 15 from the middle, tenths of millimeters, and each set is separated by 15 units, just so that by the error of the test, there is no overlap. So they are separated. Now, of course, nature abhors a vacuum, and people wanted to drive a half grade right up the middle. And so now we do all talk about half grades, 1.5, 0.5s are the 2 most common half grades. And they've been defined somewhere in between a 2 and a 1 or a 1 and a 0, but the NLGI doesn't recognize those. So those are not official grades. Those are whatever the manufacturer or the end user has defined as a grade. But I do suggest they remain 30 points. There's a reason for that. because of the error in the test, and that they do have some overlap and non-overlap between each other. Probably the most common grease grade sold is grade 2, followed by grade 1. But there are applications that use a heck of a lot of zeros, double zeros, and triple zeros for pumpability, so they're very soft. And as we just talked earlier, the stiff greases aren't really used as much anymore. Some grade 3 products, and they have their reasons in some applications, but 2s and 1s are probably the most common. And so, is the penetrometer the best way to do this? Probably not. Rheology, everyone talks. The rheometer will give you the precise number, and you can develop calculations and formulas. The problem is a typical rheometer will cost you about $80,000. A good one. A penetrometer might be $800 to $1,000, and you can put these throughout the plant, and if so the operators can measure at real time and do things like that. And you know what? It does a good enough job to get us through the day. But there is always a move afoot for newer and better, and rheology would be the one to choose. It's just practicality compared to how easy it is to set up a penetrometer, have half a dozen of them in your plant site. It's much easier just to maintain this. So I don't think the penetration test will ever go away as the way of selling grease. So I mentioned that we have the GCLB specification that was created, launched, I believe, around 1989. I'm told it took several decades to negotiate and develop and put together, and they probably had to create some tests. But what it is it's a consolidation of a number of tests that will define a grease for a wheel bearing and for chassis points. Now, more and more, nobody lubricates a wheel bearing after the factory fill, and almost nobody does chassis points anymore on any new vehicle. So are these really being sold and used as for their original intended use? No. It became quickly, as I say, there was no other specification on the market for grease. There's nothing to define what is a grease other than a bunch of tests. Everybody was quoting different tests. So this became, as I say, the de facto test bed or test for a good grease. And overall, it's not bad. Now, the problem is over time, we've discovered some of these tests have some issues. Their validity in measuring what they set out to do is maybe a little more suspect, but overall, it performs quite well. And you can see some interesting tests in here, like the fretting wear test was introduced, and it's on the LB part. And that was introduced, as I'm told, to simulate the vibrational wear on vehicles when they were being transported from the manufacturing site, the assembly point, to wherever they were going, either by train or by truck. That vibration was actually showing some wear patterns during transport. And so the fretting wear became a good test to ensure that those parts were protected during transport. And then it became just a good test where you do have any vibrational wear that it can measure that. But some of the others for the wheel bearing life test, the D3527, anybody who owns one of those tests would really now say it's not worth running, but it's still there, and I'll get into that one in a moment. But it isn't a very good test for measuring the actual life of a wheel bearing. But it was designed to be cheap and something that every lab could possess. And it did its job for the most part, and is still, of course, part of the specification now, but we're certainly looking at replacements to that. And then other things like elastomer compatibility. So again, this test and this test regimen looked at a number of characteristics within the grease and gave a good result for what is a good grease. But as I said, a few years ago, one of the working groups at the NLGI was created to take a look at that GCLB test and to go over some of the issues that I just mentioned. The bearing life was not the best. Threading wear had some issues. There was another one of the tests was not the best. So we started talking about it and what could we do? And in particularly, it did focus, I have to admit, on the wheel bearing life test. And in the end, the decision was made to create a new and improved specification, to leave the GCLB the way it was. There's well over almost 300 products remain registered today, certified by the NLGI. We don't want to disrupt that. We think that there's still value in that. So we set out to create what we now call the HPM test. And the goal of this test, when we designed it, was that the specification limits would be challenging yet achievable. And it was adopted by the NLGI Board of Directors in early 2020, about mid-2020. In early 2020, we actually had a steering committee that started the specification. We then had what was to be in person, but COVID stopped that. But we had a virtual roundtable where I believe about 40 or 50 experts from the industry came together and spent a day, actually it was 2 days, I believe, talking about the specifications, the specification limits, and we fed all of that information back to the steering committee, and they ultimately came up with what is the test regimen for the HPM spec. The one issue, though, was that we recognized that the D3527 was not a good enough test to impart any sort of high temperature or long life component of the HPM. And we did not believe that the existing tests like the SKF tests or the FE9 test were really valid tests to introduce because they're very few to be found, they're very expensive to be run. We did not want to do that. We then looked at, could we redesign the 3527 test? And that was decided that by the time we redesign that or fix the problems that it had, we would end up with a new test to begin with. So that's the decision we've chosen. And there is now a consortium being formed in conjunction with several of the equipment manufacturers to design and build a new bearing life test that will be better functionality than the 3527, but be much more economical to operate than the FE9s and the other tests that are available. And that is currently underway. I'll discuss that in a moment.
Wayne, I have a question regarding the GCLB.
Yes.
Before the meeting, you mentioned that NLGI is going to Dubai.
Yes.
Essentially for conference and so on.
Yes.
So the markets, in the industry, we see a lot of different pieces coming from different places all over the place. Specifically, when we go to like a trade show or something like that, and the greases don't necessarily have the GCLB spec. I'm guessing this is because of the certification process. Doesn't mean that the grease will not pass the test. It's just that it hasn't been registered.
It's not certified.
It's not certified. So there is an written across from
Right.
NLGI to another
Yep.
particular body of knowledge or something like that from, let's say, Australia, or it's an written across that will be comparable to the GCLB.
There's a Japanese wheel bearing, which is basically looks the same. So there's a JSO under the Japanese Standards Association. They have a similar one to the GCLB. And then the automotive companies have their own internal specs that match the GCLB. As well, the GCLB was actually not only are the individual test methods part of ASTM, but the overall specification is an ASTM specification, P4950. You can follow that. It's right there, and it has the actual specs to pass. What the NLGI provides is a true certification of it and a logo. That isn't to say you can't make the claim. We can't prosecute you for making a claim that yours meets GCLB. But if you were to use the NLGI logo that says certified, but it is not certified, that is, we can go to court over, but we can't challenge.
But it will be suitable for use.
It could be suitable for use, yes. Unfortunately, they're under the trademark laws and whatnot. NLGI cannot go after anybody making claims to be GCLB. So then it's up to you or up to the end user to say, do I believe their claims, or would I prefer to see something that actually has the NLGI certification mark on it, which says that a third party has said this meets the actual GCLB.
Thank you for that. And you mentioned that there are 300 products or 300 manufacturers that are right now with NLGI.
It's 300 products. So several companies have multiple products.
300.
Yes.
So
It's about 280, somewhere in there. It varies a bit.
Just to point this out, I believe some of the, only in China, for example, there are 5,000 different. So,
Fair enough.
Yeah.
As long as they're not using the logo,
yeah.
they're not infringing on what we've stated. So it's really, again, it's the certification value is to the end user and the comfort that they would have that it is certified versus claimed. The one thing that you're going to notice in the HPM spec that I'm about to present is that we have removed the dropping point. So the one issue with the GCLB, by including the dropping point as part of the specification to the spec, the dropping point is set at a minimum of 220 for the wheel bearing grease, 220C. Well, lithium 12 grease will not meet a 220C. You have to move to a lithium complex, or a possibly heavily additized lithium grease might meet that 220. But the problem with this is that while we don't, anywhere in the GCLB, it does not state specific thickeners can or can't be used. The dropping point immediately eliminates simple soaps. They're all gone, so they're not available. When you're going to see the HPM spec, we have removed dropping points. So the HPM spec is potentially achievable by any thickener type, based on there is no dropping point spec as part of it. And the reason is that we've had a lot of discussions internally. The steering committee and others have come to the determination that the dropping point is not the best indicator of operation at elevated temperatures. So it is a good quality assurance tool, but it's not an operability tool. And there are better ways to measure it, and we've removed it from that. And this is what the HPM specification looks like. So this is called the core specification. All products have to pass this spec to be given the label and the certified HPM spec or HPM core spec. And we've broken it into sort of 5 areas of focus. One is on the structural stability of the grease. One is on the operating range. Now for the core specification, it's relatively moderate operating conditions. One area is on tribology, that is the load and the wear performance. Another is the wet environment performance, so corrosion and water resistance. And then finally, a compatibility with materials, including copper corrosion as well as elastomer. So we've done this, but many of the tests look the same as the GCLB. Things like oil separation and storage, Now we use a different low temperature torque test. The one in the GCLB is a tapered roller bearing. We use the ball bearing D1478 test, which we believe has much better precision, more relation to actual operating in the field. But the 4-ball wear, the 4-ball EP, the same tests used in the GCLB, the water resistance, the water washout, the D14 or the 1743 corrosion test. All of these are common to both tests. And we found that, as I say, they break into these categories that overall define a very good grease for reuse. That was our goal. We wanted to find a number of tests in different areas that were able to characterize the performance of the grease in various ways. And these are the ones that we have chosen. And then, as I say, we sat down and we came up with those specifications. Now, the one thing that this does limit is it only talks about grade 3, 2, and 1 grease. So it does not, grade 0 and others are not part of the specification. So it's only in that range that we're looking at. So as I say, I just highlighted those areas. What we did add were enhancement tags. And so we focused on 4 key areas. An enhancement tag for water resistance, 1 for corrosion resistance, 1 for extremes in load, and 1 for extremes in low temperature. The one that's missing, as I say, I'll talk in a moment, is the anything to do with high temperature. So we've got these 4 enhancement tags. And the way these work is you have to pass all of the core tests first. That's a given. All products have to meet that. And then you can submit and have tested the additional testing for these other tags. Now, some of them are the same tests that are up above, but they are a tighter specification, like the water resistance. Water washout is now 5 maximum. And if we go back here, the water washout was 10 maximum in the core. So to get the enhanced water resistant tag, your water washout would have to be below 5. We add a water spray off and a roll stability in the presence of water. And that is our water resistance tag. And the thinking around this one is, if you've ever pictured throughout your lives, and Brian will be probably one of the, and Glenn, not to point both of you out, being around the industry for a very long time, everyone claims my grease is a water resistant grease. Well, now there's an actual spec that the industry experts have defined or characterized tests that will say, yes, that is a water resistant grease. Spray off, washout, and mechanical stability in the presence of water. So that's kind of the reasoning and why we've added these additional tags, and the core itself is to start to lay fact to claim.
I have many questions because it's a great presentation. Let's say I'm a lab somewhere and I'm formulating a grease, department or not, doesn't matter. That grease passed all the tests, but never been in the field.
Right.
You still certify that grease? Never been into any equipment?
This, we do not require field experience. No. What we will require at this time, although we are looking at some changes, but right now the way it works is you submit your test data set. Typically it's third party, but it doesn't have to be. You submit what you expect your tests to be. It goes to a third party who then run all of the tests as part of the fee to register the product. They run all the tests. They will report back to you any significant deviations from your test set, just so you know that, hey, you claim this, we see this, but they will pass or fail your product. So their first goal is to pass it, but they will also give you feedback as to whether what you're claiming is not what they're seeing. So you get a little bit of a benefit on both sides. But the bottom line is the product is tested against the spec and certified.
So you don't have to go to the GCLB spec first and then you get to the other one. You can
No.
go all the way to the test for the.
There's no GCLB part of this. This is, now, many of you may have test
They are
data.
already GCLB and then they go for that one too, but.
I'll talk
You can
about that in a moment, but they're not, right now, they're two separate things. This is a whole spec on its own. And then, as I say, we've got the other enhancement tags. Corrosion resistance, so now we add in salt water, synthetic seawater, and a couple different methods. MCOR becomes part of this test, both the core and the enhancement tag. So we get some dynamic testing in there. Under high loads, one of the things we've now introduced, not in the core, but in the high load spec, we've now introduced SRV. Yes, it's an expensive test and it is maybe a little less available, but it's not bad. There's quite a number of labs now that do offer SRV testing, and there are some good methods designed within that to measure friction, wear, and EP, and we've built a number of those into the enhanced tag. And then on the low temperature, we use the same bearing life test, but what we do is we just drop the temperature and expect a performance there. And then for the low temp, we also now add mobility and the flow pressure test. Now, so that's the only non-ASTM method in the set is the DIN 51805, which is the flow pressure test. But again, it has become fairly common, or they're available, and it can be run. And so the enhancement tags, as I say, we've tightened the water washout specification. We've done some, so we've used some of the same tests and just enhanced the spec portion, or we've introduced some new specifications and new test methods for these enhancement tags. So you can have the core spec plus water resistance, core spec plus corrosion resistance. You could have water resistance and corrosion resistance. So far, nobody has all four on the same product, but there is, I think, one or two now that have three of the four enhancement tags. Some of these areas are mutually exclusive. So to get low temperature, you typically have to use, to get those low temperatures, you're looking at either semi-syn or synthetic to get it to operate the way it does at -30 and the pumpability. But to get water resistance in that same grease, you're likely going to have to add polymer, which is going to detract from your low temperature and your pumpability. So there could be a balance there. So again, getting all four specs will be a bit of a challenge. Nobody's done it yet. I know some are talking about it.
You think we'll be able to match all of them?
Calcium sulfate.
Even at low temp?
Yeah, that's very close.
I think
Minus
so.
40?
Maybe. No, it's only -30.
Minus 30?
Only can touch.
It is multi-use.
But maybe I'm just joking, but
Yeah, I know.
I'm saying other ones. So
So I recall having to make stuff work at minus 40 on ship loaders that are on northeast coast, Canada.
right. It's synthetic typically, or a very low, or a low thicker content, or a low NLGI grade. But again, remember, you can only go as low as a grade 1 for the NLGI HPM spec. So it's not easy. So just a comparison of the GCLB and the core. Overall, the core, we've added more tests for each of those categories that I've mentioned. And we focused just a little bit more on those tests and how they're run and the conditions they're run under to give us the most value in the test and the response. But overall, they do cover a wide range of testing. But I have to admit that HPM just is a much broader, more robust specification than the GCLB. So we are in the process. We do have mapped out what would be possibly a high temp or a long life. We haven't decided yet. There is a committee working on that, one of those 33 committees. They are designing this, but they're not going to mention anything until we have a bearing life test. And There is no sense launching it with some tests like oxidation tests, etc., and then finding out later that you would have to modify your grease to pass the bearing life test. It would just be a nightmare. So for the high temp and long life, at this point, they will not be launched until we have that bearing test method. We need the dynamic test in place. So there is a consortium. We are currently, we're about 4 companies short of our goal to keep the costs where they are. So NLGI is deciding whether we're going to invest a bit more money in it. But what that consortium is looking like is it will be a 3-year effort. First 2 years will be just meetings and feedback, thought process from the consortium members to the designers of the equipment. That will right now look to be about $25,000 US each year. But in the 3rd year, at the end of the 2nd year, you will receive one of the test equipment, and it will randomly be either whichever manufacturers come forth, they will produce enough equipment to service all the consortium members plus a few, and you will randomly be given one. You won't get to choose whose you get to test, but that will become your piece of equipment. So part of that money is not just to pay for the design and to help offset the costs of the running the program, but you will also possess at the end of it one of the pieces of equipment, which we've calculated will probably be close to the amount of money that you have put in, probably be in the 70,000 range by the time all is said and done. So the value is there, and you get to participate from day one. You get to run the tests. So part of the requirement in that 3rd year will be to run a number of standards. It may take half a year's worth of testing. You'll be on the hook to provide that, because that data will be needed to build the case for the ASTM, to create a method and to certify and to do all the statistics and whatnot. So that's the goal of the consortium. But the other half of that year that you own that equipment, before anybody else in the industry, you get to play with it and you get to see what it can do. So there's a benefit there. And as well, you're participating in the launch of a new test method. So we are still looking for some additional consortium members. So if any companies are interested, we're certainly looking to do it. But we believe we've hit a number now that we can move forward, and that process will be starting shortly.
Our prototype of the equipment?
We've defined it. One of the things that we've defined is it will operate at least 3 different bearing types, possibly a 4th, but there's some question around the 4th bearing that was chosen. There may not be a bearing of similar size, that it may be difficult, but a minimum of 3 different bearing types. Now, that said, the test method that is developed for the HPM may only focus on 1 bearing, but the overall method, the equipment, will be very flexible in what it can run. It will only be 1 head versus like FE9, you have 5 heads. That's why it's as expensive as it is. So 1 head, like 1 oven, 1 bearing. We don't know the exact design of how that bearing is going to look. We really don't like the 2 bearing system that the 3527 has both bearings in the oven. The FE9 just has 1 bearing. It has an extended and separate bearing running keeping the shaft level. We don't know. I mean, there is a design out there. There will be some additional consulting to refine that design. But of course, it needs to be able to vary the temperature, vary the load, vary the speed, etc. So it will be a very flexible test if it all comes together.
This process was done before.
Yes.
Even in the past, so
No.
it's been funded by the same members.
No, nothing has been funded yet. We've only been, like an RFP, so to speak, has gone out to the manufacturers to be part of this consortium with a rough design requirements. But the final design will take this next 2 years.
Sure, but my question is, when the other tests in the past, on equipment, it was the same kind of model?
No.
Is it the first time it's ever done?
There's been consortiums in the past on some testing, but the other option is just to let the bearing manufacturers come up with something based on a desire by the NLGI.
So this is innovative.
We felt this way would drive it to a quicker conclusion and a potential successful conclusion. We hope. So the last thing I want to mention is just about the market. I mentioned that the NLGI has this really good production survey, and I pulled up some data here from, it's always 1 year in the past. So the 2025 survey is 2024 data. This is actual 2024 data. And basically you can see for the global production, now I'm not saying we have everybody. There are some gaps, and we continue to work on closing those. We believe North America is very accurate, and Europe is also very accurate. Outside of that, it falls out a little bit. So that's why I'm only talking here North America and global. There's probably a bit more in the globe, but let's just say right now what we captured was over 1.1 million kilotons of grease. We expect, from what we've seen, China to be about 400,000 kilotons of that. And as you can see here, North America was about 167,000 kilotons of produced grease. Now, this isn't sold. This is produced in the region. This is not sales. And you can see that lithium in the global market, lithium and lithium complex occupy at this point, what is it? It is 56% of the market. Lithium calcium, if you throw that one in there, maybe it's about 58% are based on lithium. And then the others fall off from there. Calcium sulfonate, which is near and dear to our heart here at Lanxess, is 6% of the global market, which is quite a bit, actually, and continues to grow, as I'll show. Now, on the North American production, the lithium products are a little bit less, but not far off. But it does flip, if you notice. It's more lithium complex driven versus simple lithium. So much more lithium complex versus simple lithium. Lithium calcium appears to be about the same amount. It may very well be the amount that was, maybe it mostly came from North America in the survey. So lithium calcium is a new one we just introduced last year. We're now asking for people to give that info as well. So I expect those numbers will go up over the next year or two, simply because of reporting rather than production. Polyurea is about the same in both North America as global, but I bet you if you pulled up Japan, polyurea would be a much, much bigger piece of this. They love polyurea in Japan. And sulfonate would be non-existent in Japan, but in North America, it's about 11.4%.
They don't use any calcium sulfate at all?
There is a little bit, but it's almost negligible in terms of reporting. When I say, I mean production. Remember, this is all production.
Yeah.
I don't know what's being sold into there, but from a production, actual made. So the desire of a producer over there to produce is low on sulfonate grease. Not saying it doesn't exist, but it's negligible on, if they have 100,000 tons of grease, it would be probably 1,000 tons at most, or even less, kind of thing. One of the things we are watching is over the year, and I've got the EU versus North America. I presented this in Lubexpo in Europe. There is a decline of lithium-based grease in both North America and Europe. And there is an increase in calcium sulfonate in both markets. Others are remaining somewhat flat, but that seems to be the trend. Now, they are not one-to-one, as I'll show, but there is definitely a decline on the lithium piece across the market. And the reason is, the bottom two first, supply and cost. There were some periods there where supply was very questionable given the consumption in batteries. Supply has opened up. A lot of new mines have come on. And so supply is maybe not as big an issue going forward. Cost. The cost on lithium hydroxide spiked tremendously, again, tied to the supply, and it has come down since that supply has become plentiful. So the numbers back down, but there's no expectation it won't go back up, especially given that companies like some Chinese companies have now intoned that they may curtail supply to drive that price back up. So everybody built when it was, they saw, you know, these double-digit, really high prices they were bringing on supply, but now that price has collapsed again. So there's probably going to be some manipulation in that market. And so that has concern for the grease producers, because there's two outlets really for lithium hydroxide. It's batteries or grease. And that's, you know, a big one. But the one that's now driving the grease market is that word reprotoxin again. It has now been classed as a 1A reprotoxin. That's lithium hydroxide. So at 0.1% in your product, residual hydroxide, not lithium 12-hydroxystearate, but lithium hydroxide, you require labeling of your product. Now, for the most part, grease manufacturers have done enough studies to say that they fully react all of the hydroxide and they are below that 0.1%. But there is no batch basis method to measure 0.1% lithium hydroxide in the grease. So there's still a big question mark there as to what that level really is on a batch by batch basis. Yes, you can send it off for detailed analysis. I still question some of that too, but that could take weeks before you get an answer back.
This regulatory is only from Europe.
It's Europe driven. But the problem is, the funny thing is, Europe typically has much higher levels. I believe Europe is a 0.3%. That is where it gets labeled. It's North America isn't the driver, but when they see something, their treat rates are much lower. 0.1 is the typical cutoff for reprotoxin. Could be. Now, the one issue that still drives that, though, is the operators who are manufacturing the grease have to handle the material that is 100% a reprotoxin. No questions, bags of it. So unless you've got good engineering controls, there is a potential that your operators are exposed to this and you have to take greater care. So that can be a driver to say, hey, if I'm going to invest in a new grease or grease technology, am I going to invest in lithium-based or will I invest in something else? If I'm going to build a kettle and put in equipment and whatnot. And so a number of these things are now driving people potentially away from the manufacture of lithium grease. Certainly driving people away to the point that they're hedging their bet and at least introducing other technologies into their portfolio so that they have an escape plan, so to speak, in place should things get problematic.
Lithium, calcium, be an answer to that?
It helps. And on the cost and supply side, yes. That's still 0.1%. I mean, it's
No
still
test.
reaction. In fact, it probably is going to even be harder to detect because now I think the calcium hydroxide will be more potential to be residual, but if you do any sort of base number testing, what are you measuring now? Is it lithium hydroxide or calcium? It's going to probably be more difficult.
That the one that is
yeah. So again, the sulfonate grease offers a lot of potential as one, and that seems to be why the growth there is people are introducing it into their portfolio as a manufacturer. And that seems to be the thing. And the only thing I just wanted to point out is, and this year will be no different, is that since 2013, I did a quick survey and there were over 15 published grease papers on calcium sulfonate complex grease in the Eurogrease, which is the European Grease Journal, covering 11 different companies. And then the NLGI spokesman in that same period had 28 published papers that discuss calcium sulfonate grease. and 18 companies presenting there. And as I say, I'm the paper solicitation chairman for NLGI. And again, this year, I would say of the 20 papers, potentially 4 or 5 will be sulfonate targeted. So people are studying it, people are looking at it, and it's a grease of interest for manufacturers.
Production cost different between customers.
Still higher, but you know what? The thing is, and I'm just speaking open here, is base oil has become the huge driver in cost now. Base oil prices, even mineral oil, have gone through the roof over the past, well, COVID, price went nuts. That has become one of the larger cost drivers versus the thickener in all cases. So hard to say. And then if you're making a sulfonate grease with much higher thickener content, you're using less of that base oil, which maybe there is a benefit to cost. So I don't think it's as big a driver of separation as it used to be. And then the last one I just wanted to point out was there has been talk about companies have promoted calcium 12-hydroxystearate grease as the alternate to lithium 12-hydroxy grease. There seemed to be a spike in China in production. We're not sure what that was, but there have been a number of papers saying how actually good 12-hydroxystearate calcium 12 grease is. Our thinking is simply the replacement of lithium 12 with another grease like calcium 12 is effectively 1-for-1. So from a manufacturer's perspective, if they move to calcium sulfonate grease, they would potentially use maybe 10 times less calcium sulfonate. So they would produce 10 times less, they would sell 10 times less. So even if there's a difference in price, they're not selling as much, their equipment is less. So I think there's a driver within the market that if you could switch to calcium hydroxystearate for a number, you get the same volume. The volume and your production capacity remains equivalent versus the lithium 12 that you were producing. Because again, it just is not a comparable grease, in my opinion, unless it's very moderate temperatures. So, bottom line is, I think I've covered quite a bit here, is that there is a lot goes into design and building of a grease. The NLGI and others are available as a resource to educate and help understand what it is you either want to make or how you characterize it. And regulatory changes continue to dog the formulator and the marketer in terms of the products that they have to offer and the design changes that are required. So I probably went a little long, but I like that would cover everything pretty well. Are there any questions? Anything online? Do I still have people online?
They're mostly all here. Does anyone have any questions online about the greases or the grease specifications?
About the grease compatibility,
Yes.
especially calcium complex polymer.
Tested. And okay, so that's one thing that's a good question, because it is something that people do ask, is again, the specification makes no claims around compatibility. The charts that you see, and can say I was one of those people who would put out charts, but I've stopped doing that. I've removed those. I no longer offer charts because they're not worth their value. You have to test a product and understand each product by product comparison, because it isn't just the thickeners. Now, calcium and polyurea, there's lots of evidence that says that they are not compatible, but there's evidence others would say the ones I've tested are compatible. It comes down to all of the other things that go into both of those products that you want to replace. So the one you're replacing may be formulated with particular additives or base oil that may not be as compatible with the polyurea grease that you want to replace, and it may have componentry that may disrupt a calcium sulfonate grease structure as well. So you really do have to test it on a case-by-case basis. And there are methods for that. There are ASTM methods. They are being re-examined and enhanced. They're okay, but they could use a little more meat to them in terms of what you should test to look at compatibility.
To see actually.
Yep. And it does come down to all kinds of things, degree of mixing. So there's a whole number of factors that really can't be captured in a chart. You really have to take a look on a case-by-case basis. And the supplier should be able to provide that service if they want to look at the businesses. They can, as I say, at this point, it's what is the method? Jeremy, do you recall?
6185
Something like
binary mixtures.
Binary mixture testing uses the roll stability test, or it can use the mechanical stability test, I believe, as well.
Just
You do
even in a
different
cup,
mixtures.
spatulate it.
So there is a method out there which is okay, as I say, to follow through. But I think that it doesn't take a lot to do that testing to give you some comfort that they are or aren't compatible.
It's not going to make any claims though, the method. So it is 6185. It's not going to say, yes, these are compatible or no, but you yourself, it's going to guide you on how you can convince yourself one way or another, whether it's compatible. And there's no way to truly evaluate it. It's just degrees of certainty and risk. And sometimes it's application specific. Like if the bearing fails and a nuclear plant's going to blow up, then maybe just go all the way, do the flushing procedures, get a new bearing installed. But if it's just something like a bicycle and you don't really see any issues, then you'll probably be fine.
Or I can see it pumping 200 or 300 feet in a dual line grease. You got 2-inch supply.
It plugs it up and yeah.
Plugs it up. You know, it softens it. That's easier to handle. Plugs up.
Yep.
Yeah, and then other applications, softening might be catastrophic, right? It really just depends. Yeah. A comment from Jim. He liked to point out that he had previously, as a chemist, moved away from calcium lithium hybrid, and he says it's good to see that we're coming back to where we started.
Okay.
All right. Well, thank you very much, everyone. Thank you, Wayne.
Thank you.
We will not have a seminar in December, but we will be back in January. So to everyone online and here, happy holidays, happy new year, and you'll see something from us at the end of the year or at the start of the next year. So thank you very much and take care. All right. Thank you, Wayne.
Thank you.
Good job.
Great.